Greetings, my name is An Jae-gyun. I'm going to talk about renewable energy and ESS. The title sounds huge, but I'd like to just talk about the fundamentals, the way the advanced countries are going into, how we can apply their ways to our market. First, I'd like to talk about the challenges of the electricity market and the role of variable renewable energy. The final target would be dispatchability. We see FIP can be the answer. The price signal in the wholesale market, it is uniform. We can expect some congestions and what would be the right pricing scheme. We need to think about LMP. It's time to think about it. And the process of renewables entering into the system, the central auction market or the transmission plan, how we can achieve integration. We need to think about those things and the role of ESS. We need to diversify the function of ESS. We saw many formulas from the previous lecture, but I have many pictures and graphs. This shows the power system of Korea. 40% of demand is from the central area, and under the 10th base plan of power supply and demand, they have a new plan. Most electricity demand are located in the central area, but when it comes to the supply, the potential is in the Honam area. If you look at the third graphs, you can see the demand and supply of the Honam area. You will see the oversupply of electricity. This area has a huge potential, so if we encourage renewable investment in this area, we will see some increase in the cost for transmission. The increase of the transmission network is something that we have to resolve. And going forward, how we can secure power quality going forward. Renewables are concentrated in the Honam area. We will see some voltage issues going forward. How we can solve this in a cost-effective manner. Third, the goal of variable renewable is predictability, dispatchable, controllable abilities are the goal of these energy. We have 6 gigawatt for direct market. KEPCO PPM is twice 12 gigawatts, and we have others. The issue of KEPCO PPA, they are not conducted in the wholesale market, so we cannot see them. They are not measured in real time. They need to be dispatchable. These are the issue of the PPA, and the curve is expected going forward. Flexibility, ramping were the focus in the past, but now cost effectively how we can secure large-scale ESS are the challenge that we have. How we can start? I think FIP premium, feed-in premium is important. The price of the wholesale market should be delivered to the variable renewable energy. Because they are not cost-effective, we need incentives. And how we can offer such incentives? FIP in the wholesale market is the solution. Then we can deliver the price of the wholesale market to them. We are selecting long-term fixed price contract. As you can see in the bottom, if we do FIP, when we have the curve, the price in the wholesale market will low, and after the sunset, we will see the change in the surplus curve. In other countries, if you change in the EU policy, in 2006, they adopted FIP obligation. And in the advanced countries, they are more than 20% of renewables. They are focusing on market effectiveness, so they are implementing FIP. If you look at the case of the Japan, you will see they moved from RPS to FIT and FIP. Now LMP, let's look at the LMP. They have congestion and loss as components. If you look at the Honam area in Korea, they have renewable potentials. If we have LMB with the same congestions in the central area and in the Honam area, we will see 20 ons of difference, and this will send investment signal to the market. It's a good mechanism. And people are talking about regional differences in the wholesale market for generators. It's not good to send signal with pricing because short-term optimization can be achieved with this theory. So LMP can prevent distortion in the market. And if you look at the process going into renewable, you will see a complex RPS, tender, SPC, spot market, and self-construction. It's quite complicated in the RPS, and we don't have central auction market. And under the 10th base plan for energy supply and demand, investment to generate energy need to be evaluated. So going forward, the central tender market will be an effective way to integrate renewable energy for the economy of the scale. And large-scale ESS, if you look at the case of the Europe, virtual power lines and other things are now being tried because they are experiencing an increase in demand for grid. NWA are one of the ways to make investment in the grid. They have many different projects, low carbon central markets and large-scale ESS are Korea is pursuing for. And going forward, we will see congestions. And under these circumstances, how we can recruit such things. Which one is right, FIP or other things? So in the 11th basic plan for supply and demand, I think those things will be pursued differently when it comes to the recruitment. And for more than 500 kilowatts or higher BESS, I'm looking at the model of Australia, community battery model. It's about 1 megawatt. If you look at the picture, if it is more than 500, they can achieve the scale of economy of scale, and these batteries can be used in a multiple way for different purposes. So if you do BC analysis, it's more than one, but they are not feasible in terms of business, so they need subsidies. If they are used for reserves for feasibility adjustment, I think they will see more economic feasibility. I think this community battery model of Australia can be adopted to Korea with some measures. They can be used as the frequency adjustment reserve. Conclusion. Consensus need to be made. For the current Korea's electricity market, we have day-ahead market, but auxiliary services or real-time markets will be introduced going forward in Korea. But for variable renewable incentives, how we can send the price signal, I think the answer is FIP. And the entering process in the central tender market, how we can recruit effectively. We need to think about this. And when it comes to the role of ESS, as the dot cover will get more serious, ESS will become more important. They can serve more than just shifting. They can be used in a multiple way, like resolving congestions, or when it comes to distribution of supply and demand by region, we also need to be prepared for that. Thank you very much. That's the end of my presentation.